Okay, today we're going to be talking about factoring trinomials when a is not equal to 1. So let me just explain to you what that means and what it's going to look like. So a trinomial is anything that has three terms, and it's always in the form ax squared plus bx plus c. And what we're going to be looking at is any time that this first number a is not 1. So let's go ahead and look at an example of this. So we are going to factor this polynomial over here, 10x squared plus 23x plus 12. Our first step is to always check for a greatest common factor or a GCF. If there is one, you're going to factor it out. In this example, there's not a GCF. Next thing you're going to do is you're going to multiply the a and the c together. So your a is the number in front of your x squared. The c is the number that doesn't have any x's with it. Multiply them together, and in this case, we get 120. Then you're going to make a list of every pair of numbers and you can multiply to get 120. So over here on the left I have this table. 1 times 120 equals 120, 2 times 60, 3 times 40. All of these are different pairs of numbers that multiply to give you 120. What you're trying to do is you're trying to choose which pair of numbers of those numbers that multiply to 120 also add up to give you b. So in this case, our b value is 23. So we're looking for two numbers that multiply to 120 and add up to 23. In this case, we have 8 and 15. So what we're going to do with that 8 and 15 is we're going to split up this middle term, this 23x, into two different terms. So I like to think about this as taking the 23x, and instead of having 23x, I'm going to have an 8x plus a 15x. So it's kind of like undoing the addition. Okay. So then our polynomial ends up looking like it does here in step 5. 10x squared plus 8x plus 15 plus 12. Now you might say, well, that's lame because now we made a small polynomial that had 3 terms, has 4 terms, so we made it worse. The reason why I wanted to do this is because when I have 4 terms, I can factor by grouping. So we learned how to factor by grouping in 4.1. So hopefully that's still present in your mind, and if it's not, you're going to want to review it. So we factor by grouping. We group the first two together, the second term, and then factor out some GCFs. Okay, let's do some examples where we actually work through them. So over here, we're going to factor 9h squared plus 9h plus 2. So first thing I want to recognize is that my a, b, and c are these numbers that are in front of the h squareds. So when I do a times c, I'm doing 9 times 2, which is 18, and then my b value is 9. So down here, I'm going to list all the factors of AC. So every pair of numbers that I can multiply together to get 18. Okay, so in this case, I have 3 pairs. And then I'm thinking, okay, which of those 3 pairs, if I were to add the numbers together, would add up to give me 9? And 3 and 6 works. So the key here is that 3 times 6 is equal to 18, and 3 plus 6 is equal to 9. Okay, so those are the factors that I'm going to use, 3 and 6. So what I'm going to do is I'm going to take my polynomial. I have 9h squared plus 9h plus 2, and I am going to separate my middle term into 3h plus 6h. I'm going to keep everything else the same. Sorry, it looks like an N. Add 2 here, and then I still have the 9h squared. I'm going to zoom in so that we can take a look at this. Now that I have 4 terms, I can factor by grouping. So I'm going to chunk the first 2 together and then the second 2 together. The GCF of my first group is a 3h, so I'll factor a 3h out, and I'm left with a 3h plus 1. The GCF of my second group is 2, and I'm left with a 3h plus 1. Now remember, when we're factoring by grouping, we really want these 2 parentheses to match. Because if both those parentheses are the same, then I can factor a 3h plus 1 out, and I'm left with a 3h plus 2. So this is my final factored form of 9h squared plus 9h plus 2. Okay. So as you look through that problem, everything that we just barely did down here, that should not be new. This top stuff That's the part that's new to this section. So let's take another look at another example and make sure that we understand what we're doing. So I want to identify my A, B, and C. And I'm going to multiply my A and my C together. So 3 times 15 is 45. Okay, and then my B is 19. And I'm going to list off all the factors of 45. Make sure I don't miss any. 5 times 9. I think that's all of them. Okay, so I look at all these pairs of numbers that I can multiply to get 45. And I'm looking for which pair, if I were to add them together, I would get 19. So if you're having a hard time thinking about this, it might help to actually add up all these numbers, add up each pair, and see what you get. So notice that when I add all these pairs up, I get 46, 18, and 14, but I never get 19. Since I don't get 19, it means that this polynomial is prime. Prime means that I can't factor it. So this just means that there's no way to break this polynomial down into two parentheses or into two factors that are being multiplied together. Okay, so don't forget, prime is an option. Okay, let's do a few more examples. One thing I want you guys to notice about the examples we just barely did is that all of the values were positive. Now we're going to start looking at some examples when my values are negative. So let's say I have A, B, and C. When I multiply my A times C, I get 2 times negative 12, which is 24. And my B value is the middle term. That B value is negative 11. So if there's a subtraction sign, it kind of stays with that 11. It stays with the number it's right in front of. So I'm going to look at numbers that multiply to 24. So I have 1 times 24, I have 2 times 12, I have 3 times 8, and I have 4 times 6. Okay. Now I'm going to actually add a whole nother set of numbers. Isn't it true that if I multiply negative 1 times negative 24, I also get 24? Because two negatives give you positive. So I could also have all these same pairs of numbers, but maybe both numbers are negative. And notice that all of those pairs still multiply to give me 24. So now what I'm going to do is I need to look for which pair of numbers is going to add up to give me 11. So we're looking for numbers that multiply to 24 that add up to give me 11, negative 11. In this case, negative 3 and negative 8 works. If you have a hard time doing this addition or multiplication in your head, use a calculator. Don't forget that you can always grab a calculator and use it. So the two factors that I'm going to use are negative 3 and negative 8. So then when I factor this, I'm going to take my original polynomial. I'm just going to copy it down first. And I'm going to zoom in on it. I'm just going to break this negative 11 up into negative 3z minus 8z. Don't forget to keep the variable with that 11. Again, that step is like undoing addition. Okay. And now that I have 4 terms, I can factor by grouping. So I'll go ahead and group the first two together, and then I'll group the second two together. Remember to include the negative with the negative 8. The GCF of the first group is just z, so I'll factor z out, and I'm left with 2z minus 3. The GCF of the second group is negative 4. Remember that when the first number of my group is negative, I factor out a negative. So I have a 2z minus 3. Now since those parentheses match, I can factor a 2z minus 3 out, and I'm left with a z minus 4. And that is my final product. If you're having a hard time making it all the way through the problem or knowing when to stop, one way that you can know that you're done is that if all of your addition and subtraction sides are inside of a parenthesis, then you're done. Okay? Alright, I recommend pressing pause right here in the video and trying D on your own. I'm going to work through it here, so you can definitely work through it with me, but I also recommend just trying it on your own, at least the first few steps. So I have my A, B, and C. So A times C is 84, and B is negative 20. So the numbers that multiply to 84, I have 1 times 84, I have 2 times 42, I have 3 times 28, I have 4 times 21, I have 6 times 14, and I have 7 times 12. Okay. Now remember that we can also have all the negative versions of those pairs of numbers. So I'm looking for two pairs of numbers that when I add them together, I get negative 20. So if you're looking at this list of numbers, if you change this middle, or the 6 and the 14, to negative 6 times negative 14, I get positive 84. And if I take negative 6 and I add negative 14, I get negative 20. Okay, so negative 6 and negative 14. Those are my two numbers that I'm going to use to break up the middle term. So I'm going to go ahead and copy down my original polynomial, 4p squared minus, I don't know why my computer keeps doing that, minus 20p plus 21. Then I'm going to break up this middle term to a negative 6p minus 14p. And I still have these other ones here. Okay. And now it's time to factor by grouping. So right when you get to 4 terms, you can just factor by grouping. And this should feel very similar to what we did last class. Factor 2p out of the first group, and I'm left with a 2p minus 3. Factor a negative 7 out of the next group, and I'm also left with a 2p minus 3. Then I can factor the 2p minus 3 out that they have in common. I have 2p minus 3 times 2p minus 7. Okay. All right. Hopefully you're starting to get the hang of these problems. I want to do a couple more that kind of highlight some different types of problems. First thing I'm going to do is I'm going to have you guys look at E. I'm actually going to press pause and work through this problem on my own. I want you guys to do this problem all on your own and then press play again and check your answer. All right, hopefully you started doing this problem and then you wondered, oh no, I'm doing something wrong because I can't find a pair of numbers that works here. When you start making your list of numbers that multiply to 100 and add up and look for numbers that add up to negative 20, you can't find one, which means that there's not a pair of numbers that works, so this polynomial is prime. All right, let's take a look at another example. Notice that the last 3 examples that we've done, your A and C have been positive, but your B has been negative. So what I want us to do is I want us to take a look at what happens if your A or your C is negative, just to get a feel for what that looks like as you start factoring. So first I'm going to identify my A, my B, and my C. I'm going to multiply the A and the C together. So A times C, 10 times negative 3, that's a negative 30. Make sure you keep that negative with it. My B is 13. So now I'm going to look for pairs of numbers that multiply to negative 30. So remember that when you're multiplying two numbers and you get a negative, one of your numbers has to be negative. So you could do 1 times negative 30, or you could do negative 1 times positive 30. You could do 2 times negative 15, or you could do negative 2 times 15. You could do 3 times negative 10, or you could do negative 3 times 10. You could do 5 times negative 6, or you could do negative 5 times positive 6. So these are all the pairs of numbers that you can multiply together to get negative 30. And I just need to choose which pair of numbers is going to add up to give me a 13. And again, you can just grab a calculator and start trying them out. You could just try 1 plus negative 30, 2 plus negative 15, 3 plus negative 10. Just start trying some until you find one that gives you 13. In this case, negative 2 plus 15 is equal to 13. So negative 2 and 15 are my two numbers that I'm going to use when I begin factoring. So let's go ahead and return to our original polynomial. Whoops. So I have 10m squared plus 13m minus 3. I'm going to break apart this 13m to a negative 2m plus the 15m. If you switch the order of those and put the 15m first, then the negative 2m, That's totally fine. It does not matter which way you do it. You will get the same final answer. So I break apart that 13. Now with my 4 terms, I can factor by grouping. So I'm going to factor a 2m out of the first group, which leaves me with a 5m minus 1. Then I'll factor a 3 out of the next group, which leaves me a 5m minus 1. So my factored form is 5m minus 1 times 2m plus 3. That is my final factored form. Okay. All right. So we've got a few more examples here. I'm just going to go through, I think I'm just going to go through 2 of them with you guys. First thing I want to do is I want to look at G. And I want to talk about a very important first step that we have not been thinking about for the last few problems. We need to look for a GCF before we start any of these problems. Okay? The last few that we did, they didn't have a GCF in them, but we should have checked. So let's check for a GCF in this problem. What is a GCF between 12, 30, and 72? You can factor a 6 out of all of those. So I'm going to factor a 6 out of that before I even start. 3y squared plus 5y minus 12. Okay, so whenever you factor out a GCF, now you're going to repeat the same factoring steps that we did before, but you're just going to use this inside piece. So your A, your B, and your C are just 2, 5, and negative 12. So I'm going to do my A times C over here. A times C is equal to negative 24. So you're looking for numbers that multiply to negative 24 that add up to 5. So I'm going to make the whole list here. If you can find the numbers without making the list, by all means, just find the numbers, okay? For some of us, it helps to just write out the list just so we can see what all of our options are. Okay. So of those pairs of numbers, I'm looking for which pair adds up to give me a positive 5, which is my B value. So I have negative 3 and 8. So then, let me grab it in black. I'm going to take my polynomial, the one that I've already factored these 6 out of, and I'm going to break apart the 5y to a negative 3y plus the 8y. And then I still have that 6 that I factored out at the beginning, just kind of hanging out in front. And now I can factor by grouping. So I'm just going to look at these 2 pieces on the inside and factor those by grouping. The 6, again, just kind of stays in front. The GCF of the first group is y, so I have y times 2y minus 3. GCF of the second group is 4, so 4 times 2y minus 3. Then I can factor the 2y minus 3 out, and I'm just left with a y plus 4. Okay. So then this is my final answer for this problem. If you had forgotten to factor the GCF out at the beginning, you could have still done the same process, but at the end, you would have one of these parentheses that had a GCF in it, which is a problem. Okay. I want you guys to pause the video really fast. I want you guys to try H and I. When you've got those 2 figured out, come back, hit play, and check your answer. Alright, so hopefully you're able to find both of these final factored forms. One thing I wanted to point out to you guys in H is that it doesn't matter which order you put your parentheses in. So if you found 2k squared times 4k minus 3 times k plus 6, or if you switch the order of those parentheses, that is okay. You could have put the k plus 6 first. Okay, I wanted to work through the very last one with you guys because it looks different because there's only 2 terms. So my a is this first term, it's the number in front of the x squared. This 4 is actually my c because the c is the number that doesn't have any x's with it. Your b would be the number that would be in front of your x term. We don't have any b's or any x's, so that means that our b is equal to 0. So let me start working through this problem. We're going to still do a times c to get negative 36. And I'm looking for a pair of numbers that when I multiply them together, I get negative 36. But then when I add them together, I get 0. And that pair of numbers is 6 and negative 6, because 6 plus negative 6 is equal to 0. So let me show you one way of thinking about and writing this. You could think about this as 9x squared plus 0x minus 4, right? 0x in there, that's just adding 0. Then I can separate this 0x into 6x minus 6x. Okay, and then keep the rest of it the same. Now notice that if I were to add this together, the 6x and the negative 6x, they would just cancel out, right? But I want them there because now I can factor by grouping. So in this first term, I can factor a 3x out, and I'm left with 3x plus 2. Second group, I can factor out a negative 2, and I'm left with a 3x plus 2. Since the parentheses are the same, I can factor that out, and I have 3x plus 2 times 3x minus 2. And that is my final factored form answer. Okay, hopefully that was useful and helpful. Make sure you have these notes completely filled out as you begin to start the homework.